to talk about new construction and some microgrid solutions. So during the course of the webinar, we're going to cover a few topics. We're going to kind of highlight them here a little bit together. What is a microgrid? We're going to cover some microgrid examples, as well as some comparisons between a traditional and microgrid. A little bit about hybrid microgrid solutions and hybrid generation, how hybrids work, what potentially would make them better than other possibilities. We're going to dive a little bit into the weeds with some battery chemistry, talk about some parallel scalability, how it affects the different sites, as well as hybrid versatility and really trying to answer the question, why hybrid? So during the course of the day, through a couple of these slides, we're going to try to take you on a little bit of a customer journey. We'll get into that in just a little bit. So first topic, what is a microgrid, right? If we're going to try to sum this up and really explain it, it's a self-sufficient energy source that serves a small geographic area. Could be things like a hospital or a college, a business center, or a neighborhood. In the picture below, if you guys are following along online and taking a look at it, we have really the center point of the technology being a microgrid controller. From that, it could include any number of these resources, right? So you could have or not have any variety of these power sources, including a traditional power grid, so your utility power supply, wind and solar, combined heat and power, energy storage, or diesel generators. Okay, microgrid examples. So a couple of them just to kind of highlight, and I think this will help us build the message of kind of the need around why the industry is moving towards using more microgrid hybrid type systems. So a traditional power grid, outages have shown the importance really of this type of technology. Some examples of that, Princeton University, prior to Hurricane Sandy, they had a microgrid that was stationary, that was up and running. And as a result of that, when outages occurred due to Hurricane Sandy, Princeton's microgrid provided reliable power. So it was really able to keep that facility, that finite point, protected and operating, right? So it increased reliability in that instance. Another example, we move over a little bit to Manhattan, New York. So Brooklyn Navy Yard, that is home to a microgrid that provides backup power for their critical facilities, a very important piece of their infrastructure. Another example, and we're using a couple of hurricanes here, but Hurricane Maria, right, in Puerto Rico, that absolutely devastated Puerto Rico in 2017. The island's government began looking into development of solutions that could really ride them through those type of events. Last one we had was Block Island, Rhode Island. Block Island became the first community in the United States to have a fully operational hybrid microgrid system. And it was around that same kind of Hurricane Sandy type time frame, so 2017. Microgrid versus traditional grid. So microgrids have emerged as a very viable supplemental or standalone system for a variety of reasons. So one of those key points would be grid independence. Power outages from grid disturbances like high peak time overloading and severe weather absolutely have a tendency to impact traditional grids at a very high level. Microgrids can really work to eliminate that. Localized reliance. So microgrids can improve customer reliability by helping to manage the power supply and the demand for a specific or localized areas. Energy efficiency, by having a lot of different technologies that can be used, you really have the ability to blend those technologies and really increase your energy efficiency. So you can use things like solar, like wind, or battery storage systematically and really time it for when it's going to be most effective for maybe cutting down peak charges, as an example. Improved maintenance with a smaller area to serve and significantly less infrastructure as compared to a traditional grid. Microgrids they're a lot easier to resolve issues when they occur, and you can usually do it in a lot shorter time frame. Okay, so we're going to dive in a little bit to a customer journey here. What we're going to talk about in the next couple of slides really focuses on a warehouse facility, a shipping facility. And it's going to start with construction phase, move to kind of an interim phase, and then look at a stationary phase, right? What the equipment or in the facility and the site will look like long term. So it's kind of talking about the life cycle of building this new business. So one important thing to note here is in the slide below, the picture below, we are under construction, right? So we're starting to really lay the foundation and build the building. Critical points is traditional power is roughly 2 years out. They may be bandwidth constricted or something like that, where they're having some struggles getting enough power to this facility. So in this case, rental generators are needed. And what was chosen is a hybrid type generator. And we'll talk a little bit more about some of the benefits of that in a second. But as you can see, we have 3 units under construction, and we are a few years out from really getting any viable source of utility power or other power out to this site. So as we move forward, kind of looking at a time lapse, we can see that definitely work has concluded. We now have a warehouse facility, but it's maybe not operable. Kind of working off of the renewable generators, the hybrid generators that we have out there, and expanding them and adding some other renewable power sources allows us to allow this facility to open and really begin work. In this case, we're still a while out, right? We're still maybe a year and a half out from having the rest of the microgrid ready and available. So again, a year and a half goes by. In that period of time, that's really what I was calling the interim solution, that the facility is still operating, right? So as a business, they're still running. But now, as you can see, traditional power, that kind of be in the top slide, that has been built out. It could probably support the entire facility alone. Diesel generators have been placed below it, which in the event of a total power outage, they could support the facility alone. And then a BESS system and renewable energy sources have been placed, which could support the facility for a period of time. If we look at those, there's multiple levels of redundancy that's at play there, right? We can really support the facility from the utility power as well as from the generator power. And we can use and implement the renewable energy and the ability to store that energy to really benefit the efficiency of this site, right? So it can be as we're going to rely as heavily as we could in this instance on the renewables and the storage of that renewable energy. That's going to reduce the cost, the utility cost, and the electrical cost for the customer. But they didn't just stop there, right? We've added diesel generator backup, and we do have the ability to use utility when we would like to. The backbone for a lot of this system focuses on a systems controller. So that system controller really has to calculate, it has to gather in and aggregate all the data from all of the different power sources. It calculates it, then it's going to be sending specific requests or specific commands to the different resources to allow them to work together, right? So we're taking equipment from a lot of different manufacturers, and we're kind of bringing it together and building a solution, if you will, out all of those different technologies. So the next piece I'd like to talk about is focusing on a little bit of stage 1 and stage 2 in that process, which really focuses around the hybrid generation portion. I'd like to take a bit of a deep dive into how that works So hybrids provide a energy efficient power generation solution, and the intention is to really optimize a diesel, right? We want to use cyclic charging to be on battery as long as we can, as well as reduce emissions, reduce the length of time between maintenances and the length of time between fuelings, right? Kind of maximize those and expand the life of the equipment, right? So in this picture below, we have a generator kind of on the left-hand side of the trailer, and that is really used only to charge the battery system that's pictured on the right-hand side. The battery then supports the load, right? So it's storing the energy and it's discharging based on what the actual load demands are. And the engine is just there. That engine generator combination is there kind of as a charging device in that instance. So it's kind of a unique take on what you might see on mobile rental or traditional diesel gen sets. And the question kind of arises a lot is, why is it better? What makes a hybrid solution viable? Why would you use it? Well, we talked a little about it. We'll take a deep dive into it now. It's things like less generator runtime. If we're cyclically charging a battery system with the generators, that means that portions of the operation, the generator is off, right? If the generator's off, it's significantly reducing, how much that generator is running. So it's decreasing wear across, the breadth of the equipment as well. If sized correctly and applied correctly, there's significant reduction in fuel costs. So some of the studies that we have looked at and information, it's up to 75% fuel cost over 24 hours. Again, depending on application, but it means less out-of-pocket expenses, and it also means longer period intervals between fueling. Longer component life. We kind of covered that a little bit on wear and tear and friction of the parts inside of that engine, inside of that alternator. By reducing those, we can lengthen the life of the equipment, and then incredible efficiency, right? So in a hybrid system, the generator really, when it is called to run, it's running at peak efficiency. So it's running up there at 70, 80, 90% of load in most cases, which is better for the engine, right? You have less tier 4 emissions issues from things like wet stacking or running underloaded. It really prevents that. So it does increase efficiency as well as reliability. All right. We're going to talk a little bit about some battery chemistry typically being used in the industry today. The two technologies we're really going to focus on is LTO, lithium titanium oxide batteries, and LFP, or lithium iron phosphate batteries. Those are two very prevalent technologies today. I would say LFP is used a lot more often than LTO, but there's some benefits and drawbacks to both. So if we look at LTO, one thing I would like to point out is going to be longer life, right? It's also going to be things like safer battery chemistry, as well as a high charge and discharge rate, for efficiency as compared. So what does that really lead to, right? If we know that those are the differences, what does that lead to for the solution? The first is lowered cost of energy. So LTO technology lasts for a very, very long time. Matter of fact, it can be up to 40 years or 90,000 plus cycles. So it's there for the long haul. It's a very, very good technology that could be used for a long duration. Safer battery technology. LFP batteries, they do have a tendency to hit a spot if not handled correctly and cooled correctly, where they can hit a thermal runaway event. And when you hit a thermal runaway event with LFP, it's important to note that it does kind of generate its own oxygen. So it's very, very difficult to get extinguished when it has started on fire. That's another one of the really large benefits to LTO technology. It really can't experience that type of thermal runaway, right? So and if something does light on fire, it's a lot easier to extinguish. The last one that I thought was important to note here was a wider temperature range. LFP technologies a lot of times are going to require some kind of environmental control, right? You got to make sure it's certain temperature as far as warm and cold, right? So you might need heaters and HVAC systems really to utilize the technology. LTO technology has a very, very wide operating range. So negative 22 all the way up to 130 degrees Fahrenheit. It can safely and reliably operate. Okay, hybrid solar option. So solar is it now that we have a diesel generator coupled with a battery technology, a hybrid generator, is there anything that we can do to further maximize the efficiency for the system? And solar options are definitely something that can be applied to this. By using solar options, it would allow us to effectively cycle the engine even less often now, right? So expanding out fueling maintenance more than just the hybrid system on its own, expanding service intervals. We're relying less on the diesel for charge of the battery by doing that. So it further reduces the use of diesel fuel, and it as a result would increase the green initiatives that would go around things like solar and hybrid generators. All right, parallel scalability. If we take a step back a little bit, we were talking about that customer journey from constructing a warehouse facility to kind of an interim system, where we're operating as a facility. We're needing some production to occur for the business. And then as they kind of naturally evolved into a full-blown microgrid system, we kind of talked about those different steps. One piece with parallel scalability with these type of systems, specific to the hybrid generation, is moving from that phase one of construction or step one of construction to step two. The same equipment that was used for producing power during construction can easily be scaled to support the load for a significant period of time. That technology really can't be understated. There really is not a lot of a limit to how many of these can be stacked together or put in parallel. So it really allows you to go from a very small system to a very, very large system very easily and very efficiently. In addition to microgrids, hybrids are ideal power. They're an ideal power generation solution for a variety of industries. A couple of them we talked about. We kind of did talk about construction and manufacturing in one, but that could be TV, film events, sporting events. It could be support in certain instances of utilities. Disaster relief. Hospitals are absolutely something that would require critical power that a hybrid system could support. Municipalities and commercial markets in general. So hopefully through the discussion that we had, we can finalize and talk a little bit about why would you look for hybrids in the future. So what makes those hybrid generators a better power generation solution for some of these, and how does it tie in a little bit for some of these microgrid applications? So just to kind of a recap here, we have talked about how it does reduce fuel costs. It can span out and reduce maintenance of your traditional diesel engines. Can expand the life of them, right? We're not running them as often as we would underloaded without that hybrid technology, as well as increased efficiencies and increased total cost of ownership, emissions compliance, and battery chemistry that's being used to hopefully make the site and the system safer. All of that can be packaged up through telemetry, through remote monitoring, so you can really get keep an eye on your equipment and how the system and the solution is performing for you. All right. Thank you very much for the time today. I hope you guys enjoyed the PowerPoint and the webinar presentation here. I'd like to open it up to some Q&A. So please, if you have any questions at all, feel free to put them in the chat and we'll do our best to answer them. If we could start off with a little introduction as well. Some of the folks online, if you'd like to put in where you work and what side of the industry you're in, or if you've had any experience with hybrid generators.
Okay, it looks like we've got one question so far. Are other fuels besides diesel considered?
I'm thinking it would be on the prime mover side, on the generator side. One interesting piece of the battery technology that would make a hybrid generator is these can be packaged as a hybrid unit or as a power module. So as far as other fuel sources for the engine, it really wouldn't be an issue to build a hybrid unit out of something like a natural gas or a propane unit if needed. Um, the base of interaction between what I would call the battery system or the power module and the generator to be used is it's effectively like an ATS start signal. So the power module generates a contact closure requesting the engine to start. And the cyclic charging is kind of handled based on that signal. So it's a very, very simple integration to take place if you'd like to use power modules on existing units. Thank you for the question. That was a great question.
Okay, next one. Can you parallel eBOS with AC solar in a microgrid setup?
So there are some caveats to that. A lot of times with the hybrid generation portion, we're using other power sources as a means to charge. But we could integrate or parallel in with AC solar if it was a following based inverter system. So if it's you would look at that almost like negative load in a way, and that would be compatible with the hybrid generation pieces.
Okay, and then do your generators meet Build America, Buy America Act requirements?
That's a great question. I may have to circle back on that one. I'm not certain that I know the answer to that, but I will ask. I'll find it for you.
Okay. And then can I connect to grid power to charge batteries for a hospital backup?
That is possible, right? So in that instance, utility would be used as a means to effectively charge the battery. I'm making some assumptions, but I'd assume you would have utility and a battery system tied into, say, like an open transition switch or something like that, feeding the load that's the hospital. In a scenario like that, we are still kind of the only power source when that ATS switch is over. We can accept really anything at a 480 volt level to charge the power modules. Another really, really good question. Thank you so much for that.
Anybody else have any other questions? Oh, here's one. Okay. What is setup required to parallel multiple eBOSes?
So the EBOS system is definitely unique based on some of the output or what we'd call the grid inverter technology. So the setup is effectively taking it to what I'd call like an I-line distribution panel, some common gathering point electrically. Once that happens, charging the units and putting them to work is really the only next step. There is no uh, parallel cables, like communication cables, that was required to run between modules. Um, so that it makes it very, very clean and very simple from a field operating standpoint to scale these and put them to work very cleanly.
Okay, anybody else have any other questions? What is the maximum number of EBOS units that have been paralleled in an application? What kind of limit is on this?
So, based on the output of the inverter kind of operating in a very small droop based percentage, and not having a need for parallel cables, we don't run into something you may see with parallel gensets on occasion, where you have a limit of 32 nodes or 64 nodes or something like that. So at this point, I think the largest application that we've done is past 90. I'd have to ask to get the exact number, and it worked flawlessly. So I don't know, as far as number of units, what the limitation would be. My feeling would be is that it would be some kind of a voltage drop based on cable link scenario. So, but quite a number of them. You really don't have the constriction you would have with standard isochronous controls and CAN addressing.